Okay, Robbie and Jesse, what do you guys have for your ballast system idea?
All right. Well, we have this water-soluble paper, and what we're going to do with it is we're going to fill it with the right amount of these lead BBs, and then we're going to tie it up, like kind of bag it with this paper, and then put it in here.
And we're going to have 3 of these with 1 in each bag, so it's about 1130 grams per bag.
Okay.
And then when it hits the water, this will dissolve, and this will just leave the BBs in the bag, and these holes are big enough so that when the paper does dissolve, they're just holding it, the BBs should fall through the bag.
Okay, what happens if you don't use the bag? I mean...
If we don't use this?
Yeah.
Well, we were trying to use the bag so it would give it wouldn't put all the weight onto this water-soluble paper, because if it puts all the weight over an extended period of time, it might break. So we were going to try to put it in the bag so that the weight would be in the, so that we would be attaching it with the bag so that the weight would be distributed in the bag.
Okay.
And the bag kind of provides a little bit of a shield from, you know, just moisture in the air, harsh-ish weather conditions. We'll see.
I guess we'll see. We'll run it through the gamut.
We're not sure. But that's just the idea behind it. You know, it may work better without the bag, and great, we can put more weight on.
And we'll have to find out what happens to that paper whenever you put it at extremely low temperature.
Yeah, that's one.
We'll have to get some dry ice and methanol to try to simulate a minus 50-degree environment.
Okay, yeah,
but you have a very tiny little sample, because I know you guys don't want to waste a whole lot of this paper.
We're limited on the paper.
Yeah, and we aren't putting it in the bag,
drop
but
it in with the
here's this.
So it doesn't take long to dissolve, and then boom.
Nice.
These just pop out.
Yeah. So
That's awesome.
So we're hoping
that'll work.
That works really well.
And so basically all we have to do is make sure that it works in really cold temperatures and
with the moisture in the air. Yeah.
Yeah, moisture in the air might be a problem.
Which is why we're going to try to double wrap it.
If it rains, we're kind of screwed. We'll see.
But
we'll look at forecasts.
Anyone's ballast system, if we ran
Yeah,
it's screwed because everything is
water soluble.
Yeah.
That's why we do experiments, right?
All right.
Yes.
All right. Thanks, guys.
Thank you.
Nick, Xavier, what do you got for your ballast system?
Alright, this is something that Vincent came up with, but what we have is 5 to 6 Alka-Seltzer pills right here that we managed to drill a little hole through, and you have 2 different string loops, one on the bottom, one on the top, and those 2 strings are not connected. And the idea is that when the Alka-Seltzer gets wet, it dissolves, and the whole thing comes apart and would release whatever this weight here is.
Okay, ahead.
Now we're gonna try how strong the Alka-Seltzer will be.
Yeah, that's a good concern, is how strong the Alka-Seltzer is. So
We tested it once with 3, and it was pretty darn strong. This is 5, and we can sort of increase it how we like.
how about swinging or rocking? Stand up and go behind the chair and swing it or rock it.
Want me to swing it right here?
Sure.
Whip it. Seems like pretty strong.
And that's a 200-gram weight in there right now.
Yeah.
200 or 5?
200 grams.
Wonder, and we need about an 8-pound payload. So, and we're gonna.
Multiple of these staggered.
Okay, how many is multiple?
3, 4 maybe? Possibly, I don't know. Depends on how heavy each of the ones is and how big each of the Alka-Seltzer packs is.
Okay. Looks pretty good.
Yep.
We'll give it a shot when we test it in water and freeze those Alka-Seltzers. See what happens with those Alka-Seltzers.
It might get brittle.
It might get brittle. We'll see.
Yep.
Okay, Banks. Can you explain your ballast system?
Yeah. We're developing a ballast system, and our main concept is baking soda up here, solidified, and something wedging it in place, whether it's a screw or copper wiring being fed through in 4 different places. We're going to try to figure out which one's best, and we're going to test it. This is a smaller scale. I used 10 grams of baking soda, 1 gram of Dextrin, and about 5 milliliters of water. And this is what that is, but with 4 milliliters of water. There's a little bit of a difference. This is more clumpy, a little bit more liquidy. But once this solidifies, we're gonna put a little like wire through here just for the concept, and then we're gonna put it upside down and see like how well it dissolves in the water. And if it does, then we will freeze it because it's gonna be at really high altitudes and it's gonna be below freezing. See how it reacts with that and see if it like still dissolves well. And another concept that we are developing is Andy is taking baking soda, putting water in it, and then freezing it, and seeing if it'll melt when it goes down, or if it'll like how it'll dissolve. Like,
Or if it just hits the water. I mean, if it hits the water enough so that the water is going to be pretty separate with the baking soda particulate in it. So it's possible that as soon as it comes down, it will release. We'll give it a shot and test it out.
Okay.
Sweet.
This is the Dextrin baking soda.
Where do you get the Dextrin idea?
I'm doing a firework right now, and we're using Dextrin, water, charcoal, and potassium nitrate, and the Dextrin holds the charcoal together, so it can be black powder pellets, so it'll give the charge.
Nice.
So that's where I got that from. I was like, well, that holds it together, and I found out Dextrin is soluble, so we're using that just to see how fast it dissolves.
Cool. All right, Mikey and Blaze, explain your ballast system here.
Alright, so basically we've got string of some kind, and it's got a weight on the end. This is just like a preliminary idea. It can be anything from like this to a rock, basically. And our idea is that once it hits the water, we have some sort of buoy system that will bring this razor up, and once it hits, come up and cut the string. So basically we want to construct like some sort of slot that'll hold it in the correct position for it to cut the string, and then the water bringing up the buoy, just like simple buoyancy, will create enough force to cut the string.
And I'm guessing that we're probably going to need something smaller than this, because if we're only going to have about 8 pounds, it's got to be pretty dense, and it's got to be able to sink for the buoy to float. So.
Interesting idea. We'll try to put it to test tomorrow
Sounds good.
or Friday.